Thanks for checking out my course. I'm Michael from 3D Illusions, and in the course we're going to be creating this really interesting scene with two completely autonomous octopuses that have got a life of their own. And in order to complete this task, we're going to learn a whole lot about Blender, including how to use geometry nodes to create much more flexible models that we can adjust and modify much more easily. We'll learn how to use attributes to make Blender much more powerful and do things that otherwise we wouldn't be able to do. We'll start breathing life into the octopus, and then we'll start getting it interacting with other octopuses and other objects. We'll teach him how to breathe. We'll learn how to puppeteer him, and we'll get him to follow a path indefinitely, and then we'll fire him out of a cannon for good measure. Before creating this practically real-time water simulation, shaders, lighting, viewport compositing, and then for super fast rendering, we'll use the Eevee render engine. So I hope you enjoy the course, and if you'd like to support the channel, you can do so in a number of ways. You can either become a member at 3d-illusions.co.uk, where you can download loads of cool stuff, tutorials and scene files and things like that. We've also got two add-ons, so we've got Turbo Tools, which is available from the Blender Market or from Gumroad, and that one will massively speed up cycles renders thanks to its ability to build advanced studio quality denoising networks, allowing you to use the lowest possible number of samples, and it will tailor those to each individual scene, automate sample settings, and give you much faster compositing. And another big feature is that it will remove flicker from animations that would otherwise require you to render for up to 40 times longer to get rid of. And I also developed an add-on called Pixel Modeler AI that allows you to copy an image from any source and then paste it into Blender, where it will appear as a 3D model. So check those out using the links in the description below. I hope you enjoy the course. Let's get started. So we'll start off, Shift A, and we're going to add a UV sphere. This is going to be the octopus's head. And we'll do F9 to bring up the redo menu. And I want the number of segments to be 3 times the number of legs. So I want 8 legs. I'll set this to be 24. That just makes sure we've got space in between each of the legs. And then we're going to need the rings so that the faces remain square to be half of the segment. So I'm going to set this to be 12, half of the 24. And now we can start creating the legs, sprouting the legs out of this geometry using geometry nodes. So we'll go to the modifiers, and we're going to add a geometry node modifier. We'll just bring up a new panel at the bottom, and we'll set this to be the geometry node editor. Now we'll click new, and this is going to create as a new tree that's going to be used by this geometry node modifier. And that's going to create as these two nodes, the input, which will bring in the geometry, and then the output, which will spit out whatever changes we've made in between. So I'm going to do Shift A, and I'm going to look for an extrude mesh node, and we'll put this in here. And this is going to extrude every single face on the input geometry. Now I only want to extrude specific ones where I want the legs to sprout from. And the way these nodes work in geometry nodes is basically they will loop through each element, in this case faces, of the mesh, and then perform the operation that this node is designed to do. And we can specify how it does the extrusion based on these input sockets and values. So to give it some information to work with, we're going to store some information in the actual geometry that it can read as it's looping through. So what we need to do is create some attributes. So let's temporarily turn off the modifier so we can see the edit mode a bit better. Go into the data panel, and this is where we can create all the different types of attributes that can be used by geometry nodes modifiers or other modifiers in different areas of Blender. So one place we can create attributes is vertex groups. So let me just bring up the spreadsheet so we can see what this does. We've got our mesh here. We've got the different domains, so the vertices, edges, faces, and face corners. And then for each of these domains, we can create an attribute, and that means that each element of that domain, each vertex in this case, can have a different value for this attribute. So if I create a new vertex group here, it's created a vertex group, and I can name this whatever I want, Michael. You see we've now got an attribute here called Michael, which means that every single vertex can have a different Michael value. So let's go into edit mode. I'll choose a few of these vertices, and I'll decide which value do I want to assign to the selected ones. I'm going to 0.436, click assign, and now all of the selected vertices have been given an attribute value of 0.436. And we can use this over here in the geometry node by Shift A, and we'll search for a named attribute. And we can choose the attribute, but it's not available currently because I need to turn the modifier back on. So turn that back on. Now, if we click on here, that Michael attribute is going to be available. So I click Michael, plug the attribute output into the selection input, which basically means as the extrude mesh node loops over every single face in the mesh, it will check if the Michael attribute has got a value greater than 0 for the face it's currently looping over, and if it has, it will class as a selection because it's plugged into the selection input, so it will perform the extrusion. So what I want to do, let's just come back over here to the data panel, is just set all of these to 0, ones I've got selected, and instead I want to select just a few of them. So I'm going to choose this one, and then I'm going to skip 3 faces. This is why we chose to have the segments 3 times the number of legs I wanted. Choose this one, and then I'm going to expand that selection by clicking Ctrl-Shift+, and that will expand the selection by pattern, so we've got the same gap between each of them. I'm going to click Assign, change the weight to 1 first, click Assign, and now just those ones are going to be extruded. And I don't want it to be individual, I want it to be all together. So untick individual, and now we've got the legs being extruded out. And it's a good thing to know as well that we don't necessarily need to do it in vertex groups anymore. We can also do it in the attribute section down here. So if I was to do the same thing, let's delete this vertex group. I've still got my selection in the viewport. I'm going to create a new attribute. I'll call this one legs. And the beauty of creating your attributes here is you can actually choose where you want to store them. So do I want to store them in the faces, the edges, or the vertices? Now, I do want to store them in the vertices in this occasion, so I'm going to choose vertex. But we can also choose the data type. So we've got all these different options rather than just having the float. So this is good to know how to use this. So I'm going to click OK and leave it on float. We get the same as before, but I've just I've created it here. And then to assign the values, while we're still in edit mode, make sure this is blue, so it's selected. We go into mesh, and then set attribute, and then we can set the value here. So if I put 1, now if we change this to legs, it's going to get exactly the same result we had before. So it's good to know that basically this is exactly the same as up here with a lot more flexibility. And just to give you one very quick example of why that extra flexibility can be useful, let's have a quick look at the mesh here. So if we go into the modifier, I'll just turn it off in edit mode with this little icon here. Right, you'll see we've got this one vertex selected, but it's extruding 4 faces. And this is because this vertex is part of each of those surrounding faces. So if I want to extrude a single face, let's go into face mode, I can't do that with a vertex attribute. What I'd need to do instead is create a face attribute. So let's go over here, we'll click plus, and we'll call this one face legs. I'm going to store it this time in the face domain instead of the vertex domain. We'll keep it as a float and we'll say OK. With that face selected and this selected over here, we'll go into the mesh menu, set attribute, and we'll give it a value of 1. And now if I change this named attribute here that this node is using to face legs, which is not currently available because I'm in edit mode, let's just come out. Change it here to face legs. You'll see it's only extruding a single face instead of all 4. Alright, so let's change this back to legs, and I'll delete this face legs attribute. There we go. So what I want to do now is extrude these legs multiple times so that we've got sufficient geometry for the legs to bend. And previously, until recently, we'd need an extrude node for each extrusion. Obviously that's very tedious. What we can do now though, thankfully, is use Shift A, a repeat zone. And the repeat zone is just a loop which will repeat whatever is inside of this area between these 2 nodes. So let's get rid of this here, Alt click and drag it, drop it on here, and now I'm going to plug in the geometry input into the geometry input there, and then the geometry output, that repeat zone in there. Now we need to specify a selection. So firstly, this repeat zone, I'll just explain how data gets passed through it. On the first iteration, it's going to use whatever's coming into here. So we need to set a new socket. Plug this attribute in there. This generates us a socket, and I can rename that socket to make it more obvious what it does. So click on this repeat zone, and I'll just rename this to the legs. Doesn't matter what you call it. It's only for our own sort of understanding of the tree. So on the first iteration, if I plug this in here, it's going to use whatever is plugged in here, or whichever value we give it in there. So plug that in there. First iteration, this is what it's using, this attribute that's plugged in. The second iteration and subsequent iterations, it's going to pass back whatever comes in on this side back to this socket to come back out again. So I want to extrude on the next iteration just the top face here of this extrusion. So I'm going to plug in the top into there. And now when I increase these iterations, you'll see it's going to use this on the way out so that it extrudes the new top face. And we can do that as many times as we want. So I'm going to set that to 15. And that's sort of the length of the leg that I want. And I'll just change the scale a little bit, the offset amount, so that these are more square. So let's turn that down a bit, somewhere about there. And then I want to scale each of the end faces when it extrudes so that it gets thinner towards the end. So I'm going to do Shift A. I'm going to drop down a scale elements node, drop this on here, and then I just want to scale down the top face of each extrusion. So if I don't specify selection, it's going to scale the entire thing. So I'm going to say just scale the top face after each extrusion, turn that down a bit, and now it's going to get those legs getting a little bit thinner each time until the end. And we can just modify this again, maybe get it somewhere more about here. Ready for the suckers. And now we've got the base mesh created, what I want to do is breathe some life into this octopus so that it can become fully autonomous and move around completely by itself. So in order to create a simulation, we're going to need to create a floor for the octopus to interact with. So let's Shift A, and we're going to use a plane, and we'll scale it up, then we'll move it down, Control A, and we'll apply the scale just so the physics system works correctly. And now we need to add a physics property to this floor. So let's just rename it floor firstly. And I'll rename this sphere to octopus. And then select the floor again. Under the physics tab, I need to set this to be a collision object. So set that to be a collision object. And I'll turn the friction up a bit as well. Maybe set it to the maximum of 80. And it is a single-sided object, so I'll leave that ticked. And for the octopus, I'm going to make this a cloth simulation. So still under the physics tab, choose cloth, and for the time being, I'll leave this at the default. And let's play this back and see what happens. And we can hide this now as well. So let's just collapse that back over. Play this back. And there you see we've got a cloth simulation on the object. So at the moment, you can see we've not got much movement happening on this object. And also, we've not got much time to experiment with the physics settings before the timeline starts again, because we've only got 250 frames. So let's just fix that first. We'll go into the output properties. I'm going to change the frame range so that it ends on something much bigger, maybe 5,000. And then for the cloth simulation, I also need that to calculate for the full 5,000 frames as well. So go into the physics tab, and then we'll go down inside the cloth settings until we find the cache. And this is basically how many frames it's going to simulate. I want it to match with the timeline, so I'll set this to 5,000. And now when I play back, I've got plenty of time to experiment with the various settings. So let's play this back. I'll just turn overlays off. So we're not getting much movement at the moment. And the way the octopus is going to be moving is by using its own sense of touch, its own sense of collision. So let's go to the collisions tab here. I'll just minimize this cache now. And I'm going to turn on self collision. So turn this on. And as soon as I turn this on, we start getting some movement. And it's based on the distance between the geometry of the mesh. So if there's any parts of the mesh where the geometry is below this distance, then it's going to instigate some form of movement because the octopus thinks it's colliding with itself, which will generate movement in the opposite direction. So if I turn this up further, we're going to get more movement. And we're starting to get some realistic, sort of completely random movement. And we can control the quality and the type of movement we get by going to the top. And then we've got the stiffness and the damping options. So the stiffness options are how much the cloth will resist moving in a particular type of way. So tension is how much it's going to resist stretching. So 15 should be fine. Compression, that's how much it's going to resist compressing on itself or shrinking. So if I set this to 0, you'll see the octopus is falling in on itself. I'll set this something maybe to 1. Shear, this is how much the faces can shear, so become sort of skew whiffed and result in like a twisting movement of the cloth. So I'll leave that as it is for now. And then bending, this is how much it can resist bending. So if I turn this quite high, maybe 5, then you'll see all the limbs and things become much straighter because they can't bend as much as they could before. It's resisting it. And then for the damping options, this is how much it tries to slow down whatever movement is currently happening. So if I turn, for example, tension or shear, let's turn all these top ones up to something really high, like 20, then the movement is going to become much slower and it will sort of come to a halt faster as well, generally. But the problem is with bending, if you set this one too high, then it's going to become a bit of a quivering mess. I don't know why. So I generally don't put this above something like 0.5. So 0.5, and then we're going to get a slower movement there. So I'll just set all these back to default. Backspace, 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 and backspace. Do the same for these. And I don't particularly want it to collapse in quite this much, but I want to control it using these springs over here so that we've still got the ability for it to move. I'm going to set these to 1, in fact. And I'm going to set the damping to 0 for all of them, just so that they can move quite freely. And to get this volume back in the octopus, I'm going to turn on internal springs. So internal springs, if I turn this on, you see it blows the octopus back up. And basically what this does, it creates sort of a spring internally between opposite vertices within this angle of each other. And then we can control how much tension those springs have got and how much resistance to compression. So we're getting quite unrestricted movement, but we're also retaining some of that volume as well. But we are getting a little bit of a shudder on there. So I'm just going to turn up damping maybe to 1 on all of these. And that should calm that down a little bit. And then we come back down to the self-collision and we can modify this value to get more or less movement. So if I turn it to 0, then the octopus is going to come to a complete stop. If I turn it high to 1, or 0.1 is the maximum, then it's going to go, crazy. It's going to get a lot of movement. It's going to push itself all over the place. Choose the octopus and we'll turn that distance back down a bit for the self-collisions. So maybe 0.06 rather. Maybe a little bit more. 0.07 perhaps. And maybe start messing about with the different options we've got up here. So I might want to turn the damping down to 0 on the bending and also on the shear. And I'll probably turn the bending and shear stiffness down to 0 as well, just so we can get a bit more movement. And there we are, so I probably prefer that. But you don't need to copy my options. Have a play around and see what you come up with until you find something you like. And if you find that your octopus is not getting any movement at all, no matter how high you turn this, it's because, if I just show you, I'll scale this up, or move it up a bit as well. If I play this back now, even though it's got identical settings, maybe not quite that big, maybe about here. Play this back. We've got identical settings, but because the geometry now is further away from each other, so all the different geometry elements are not within this distance anymore. And no matter how high I turn this, we're not going to get the amount of movement that we want. So in that scenario, what you'd need to do is scale it down. So scale it down. I'll move it back down again. Let's just check what we've got over here in the item menu. We can see it's quite big. It's 3.58 meters, and it's 0.925. But if I scale this down to 0.5, or something like around that scale, and now play this back, you see we're going to get a lot more movement with this setting. So the smaller the object is, the more impact this distance slider is going to have. So 0.01, let's play that back. And we're hardly getting any movement. I'll just turn this up a little bit. And even on 0.2, we're starting to get some movement on the octopus. Whereas before, when it was large, even at 0.1, we were getting nothing. And unfortunately, Blender does limit you to not being able to put more than 0.1 in there. It's a little bit unfortunate. It would be nice if you could, if it wasn't limited, but unfortunately it is. The next thing we're going to do is start putting suckers onto it, and also making it look smoother and things like that as well. And then we'll look at how we can get it to interact with other octopuses and other objects. And then something really cool, we're going to look at how we can actually puppeteer the octopus. So we'll go back to the modifier panel, and I'll isolate the octopus, and we'll go back to frame 1 as well. And now we get a good look at the octopus before it starts being manipulated by the cloth simulation. So I'm going to create another modifier, and again it's going to be a geometry node modifier, and it's going to go after the cloth simulation. So the reason I've done it this way is because the cloth simulation is going to work much faster if it works with this low resolution mesh that's been created by the first geometry node network. If we put the cloth simulation after the suckers, where we've done, added lots of geometry, then the cloth simulation is going to be quite slow to calculate. So we click new, and it's given us a new network. I'll just call this suckers. I'll call this top one legs. I'll click back on this one here. And I want the suckers to only come from the bottom of the geometry. So let's go into edit mode. I'm going to turn back on for this one, for the top geometry node modifier, the effect edit mode. So we see the result in edit mode. Into vertex mode. And I want the bottom vertex at the middle of each of these legs to have a sucker attribute with a value of 1, so that we know where to place the suckers. So into the data panel, we'll create a new attribute called suckers. It's going to be on the vertices again, and it's going to be a float, and we'll say OK. And I'll select the vertices that are at the bottom of each leg. Go into mesh, set attribute, making sure it's selected over here, so it's blue. Set attribute, and give the selected vertices a sucker attribute value of 1. And then Shift A down here, I'm going to extrude the mesh again, drop that in there, Shift A, named attribute, I'm going to plug this, we're going to select the suckers, and then we're going to plug this into the selection. And now only the faces that are connected to a vertex that's got a sucker value greater than 0 will get extruded. And because the original leg extrusion vertices inherit the sucker attribute from the original face, that means that attribute will go all the way down the leg. Alright, so let's scale them in a little bit. Shift A, scale elements, drop that in there, and then I want to scale the top of the extrusion. Scale those in, and now you can see we're starting to get the beginning of our suckers. Now I'd like to have the option to remove these suckers that are on the body, and I would also like to have the ability to control the scale of the suckers depending on how far down the leg they are. So we need to create another attribute, but instead of doing it in the data panel over here, we're going to create it in the first geometry node modifier. So we'll click on the top geometry node modifier to open up its node tree. And all we're going to do is store in each of the faces of the extrusion, of each extrusion, the iteration number, so which count the loop is currently on. And to do that, we're going to Shift A, and this time we're going to store a named attribute. So we're going to create one. We'll put this after the scale. Move that up a bit. And I want this to be an integer. It doesn't need to be a float. We don't need decimal places because it's just 1 to 15. And I'm going to store it in the faces, so those side and top faces of the extrusion. I'm going to call it extrusion count. And then we need to give this a value each iteration of the loop. So we need an initial value to start with. So let's click on the repeat node. We'll go into the end panel, and then we're going to add a new socket. So we'll click on plus, and I'll call this new socket the count, and I'll make it a integer. And now it's going to use this 0 value on the first iteration, and whatever we pass into here, it's going to use on the following iterations. So we'll drag this one across, we'll leave it on 0, drag it to here. I'm going to choose math, and I'll choose the add option. I'm going to add 1 to it, and then we'll plug this into the value of the store named attribute, and we'll also plug it into the repeat node output for the loop to use on the next iteration. Okay, so let's go back now. We've created this new attribute. We'll go back to the second geometry node modifier, and we can use that attribute now. If we do Shift A, named attribute, and I'll click on the name button, and we've got access to it in here. So click on that. And if I want to view this, I'll Control Shift click on here before we start doing the sucker extrusions. So that gives us a viewer, and we'll plug the attribute here into the value. And we can see that the entire octopus has turned white. So basically this means the value of all of the faces on the octopus for that particular attribute are equal to 1. If it was 0, it would be black. And the reason for that is if we go back to the geometry node network, I've chosen to store the named attribute in all of the geometry. I haven't specified a selection where to store it, and I only want to store it in the side and the top of each extrusion. So what we'll need to do is just grab the top, and we'll plug that in there. But now the problem is, let's just do it firstly with the side, in fact. If I go back to this modifier here, we'll click on the viewer, we've got it on the sides of each extrusion, but on the end, the far end, we haven't got it. So we're not going to be able to extrude those little fingers out that I had on the original one. In order to do this, we'll go back to the first geometry node network, and all we've got to do is add the top and the side together and then put them into the selection as one. Let's just move those up a bit, and we'll do Shift A, math, drop this in between the output and the selection input, leave it on add, and I'm going to plug the top in there as well. So basically, we're adding together the top and the side and then putting those into the selection. So if we go back to the second geometry node network now, we'll click on the viewer again, you can see the end ones have now turned white as well, indicating that they've got a value, an extrusion count value, greater than 0. And we can actually see those values if we just go in here, and I'll turn on attribute text, and now we can see what those values are for each of the extrusions. So it starts on 1, 2, 3, 4, etc. until it gets to 15 on the end. Okay, so let's get rid of the viewer. And now we can control the scale of these extrusions based on the extrusion count. So I'm going to do Shift A, I'm going to put a math node down, and I want to say whatever value this is, divide it by the extrusion count. And that's going to make it get smaller the further down the leg it gets, because as the number becomes bigger, obviously, if you divide 1 by 15, it's going to be much smaller than at the top where you're dividing 1 by 1. Okay, so I'll plug the attribute into the bottom, I'll change it to divide, and now I'm going to plug this into the offset, and I see the offset now, the extrusion rather, is bigger at the base than it is at the tip. And I might want to control this visually using a curve. So let me just do that. So instead of having 1 to 15, for the curve to work, so Shift A, search for a curve, and go with the float curve. In order for this to work, this is only going from 0 to 1. So all the numbers above 1, we can't actually see and control. So what I need to do is remap this range, so that instead of being from 1 to 15, I'm going to make it 0 to 1, and then it will fit inside this curve portion. So this one bit of curve here will represent the entire leg. So Shift A, and we're going to look for a map range, drop this in, and I'll do it from 0 to 15, from 0 to 1. And now we've got this effect here. So we can control the scale. The bigger we make the number, the smaller the extrusion is going to be. So bring this right up. You see we're getting, we'll make it flat in fact. Then you see it's the same length all the way down. I can just control the overall amount with this value on the divide node. Okay, so we've got a reasonable extrusion amount. And what I can do now is start modifying this curve so that if it's a bigger number, the extrusion is going to be smaller. So let's put this up in the middle. They're going to get small in the middle. And if I bring it down here on the end, you'll see it's getting bigger on the end. If I bring it down like this, then it's bigger on the end for a larger amount of time. But you don't want to go too far out, otherwise the collisions are going to look a bit strange because we've got our cloth collisions before we had the suckers. So if you're sticking out too far, these are obviously going to be going through the ground because the cloth simulation was calculated based on the previous sort of more simple state when it was like this. We could put the cloth simulation after the suckers, but that would slow down the simulation a little bit. It just depends how big you make your suckers, whether you need to do that. Right, so I'm going to make this a bit more of a reasonable value. And now I'll control the overall amount with this value here. And now I'm going to do the same for the scale. So Control Shift D will duplicate it, but also keep it wide up. And then we can plug this into the scale over here. And now the scale of the faces is also going to be controlled by that curve so that they match the scale of the extrusion. And I'll probably make those suckers a bit bigger actually, just near the body. Now I don't want those suckers, as I said before, on the body, just here, because they're overlapping with the suckers on the tentacle. So this is actually very easy to do because we've got all the information we need now. We've got the sucker values, so the sucker attribute, which basically says if any of the faces are touching a vertex that has got a sucker value greater than 0, then extrude that face. And it's just these inner ones here, these inner vertices there, in the middle of each extrusion, that is going to be that the faces are touching. So I've also got the extrusion count. Now if we look at the extrusion count, Control Shift click on this node here, and then I'll Control Shift click on the extrusion count so we can see it. You'll notice that the faces of the body have got an extrusion count value of 0, of course, because we didn't start adding the values until we started extruding. So it's 1, 2, 3, 4, etc. So to make sure that these inner faces on the body don't extrude, all I've got to do is multiply this by this. So if this is 0, no matter what this is, even if it's 1, it's going to be 1 multiplied by 0 equals 0, so that that face will not be classed as a selection, and the extrusion node won't operate on it. So we'll do Shift A, we'll put down a math node, we'll drop this here, change it to multiply, and then we'll plug this one in there. And if we just get rid of the viewer node now, you'll see it's only extruding the faces of the leg. So that's the beginning of the suckers. Obviously now we need to get the little hole that goes inside. So this is very straightforward. We're going to go over here and I'm going to add another extrusion. So I'll just copy this one, Shift D, bring this across, and I want it to be an extrusion amount of 0, because basically I'm going to use this as an inset. If we look at what it's done, we've basically got this face here. There's two faces there now. We just can't see it because the extrusion amount is 0. So in order to see it, I'm going to scale it inwards. So Shift D, grab this one, and now we'll scale it on a negative amount and make sure we only scale the top, so the new extruded face. And now when I inset that, you'll see it's insetting that face over there. So scaling that in to give us the inset effect. And I want this also to be relative to the distance down the leg as well. So I'm going to grab this one, duplicate it with Control-Shift-D so I keep the connections on it, and then we'll plug this into the scale. And I'll just bring that down a bit. And I don't want it to be scaling all of those side faces as well. So I just need to make sure that when I extrude the mesh here, I'm not extruding all the faces, only the top of the previous extrusion, which is here. So let's grab this, bring this across, and now that's limited it just to that extruded area. And finally, with that done, we can add another extrude mesh, Shift-D, and this time we're going to extrude. Let's go back in solid view. We're going to extrude inwards, so negative number. And again, just on the top. So let's grab this one, bring it across. And there we are. And I want this also to be the amount controlled by this same curve. So Control-Shift-D, bring this across. I'm going to plug this one in here. And make sure I set this to be a negative number. And there we go. Just make sure they're not poking through anywhere. And there we are. So we've got our sucker, and we can control it with these divide nodes. So we can change the scale if we want a little bit on this scale here. Maybe we want it a bit bigger. We can change how deep it goes with this final extrude mesh here. Just until you get a result you like. And of course, we don't make sure we don't get any overlaps. So that is a bit too big there. So I'm going to bring that in a little bit there, and also in a little bit there as well. And for this extrusion, maybe I'll just bring that out a little bit more. So there we are. Let's come out of edit mode into object mode. And if we come out of isolation view, so / on the numpad, and even if I add a subdivision modifier after this, so generate a subdivision modifier, subdivision surface. I'll set this to 2 iterations so it's nice and smooth. Right click, shade smooth as well. Press play. The cloth simulation is still being calculated on this low resolution version, so we're still getting reasonably good performance. And just one last thing, go back to the first frame, go into isolation mode. I think the octopus, it looks a little bit boring just having suckers underneath the legs. So I'd like them to stick out of the side as well. So let's go into the data panel, and the suckers attribute, you remember at the beginning, we've stored it just in the vertex at the middle. So only these 2 surrounding faces that are touching it are going to be extruded. Now what we can do instead is store this, we'll convert it to store it in the edges. So let's just have a look what that's going to do. We'll turn that off in edit mode. Into the data panel, when we convert this current attribute to the edge domain, it's going to make it so that this one, this one, this one, and this one have also got the sucker value of 1. And that basically means that anything that's touching these are going to be extruded, and that's going to include the side faces on the side of these legs. Alright, so let's go and we're going to convert this. We go back into object mode. We're going to convert this suckers into, instead of a vertex domain, we're going to put it in the edge domain. We'll say convert, and now those suckers are sticking out of the side. We might want to modify the mesh a little bit, just because these could do with sort of sticking out at more of an angle. So I'll go into edit mode, and all I'm going to do to achieve that is make it so that the bottom side here is just a bit more like this, and now the suckers are going to be sticking outwards instead of before. Just undo that. They're sort of sticking inwards a little bit. So move those up just a tiny bit on the global Z. And now you can see these suckers are not sort of scrunched up quite as much as they were before. Let's have a look at this. I think that looks much better. And we'll play this back. And there we go. I think that definitely looks a bit more gruesome. I've just noticed actually, if we look at here, we are getting a little bit poking through. So I'm just going to need to modify the suckers geometry network a little bit. Go back to the first frame. Let's just see if we can isolate that and see where that problem is. So just on the end there, we've got the extrusion of the hole just going through a little bit too far. So what we can do is come over here, find the one that extrudes inwards, which is this one, and I'll just make this not quite as much, so -0.1. And there we go. Let's fix that. Okay, and then back into object mode. And then next up, we're going to get the octopus interacting with other objects. We'll look at getting some additional movement using force fields. And then we're going to look at how we can puppeteer the octopus so we can actually manipulate it manually. And then we're going to build that really realistic scene that we saw at the beginning of the course. So firstly, the easy way to do it, let's just bring this down a bit now. The easiest way to do it is to duplicate the mesh inside of the same object. So let's go into edit mode. And we'll just turn overlays on. I'm going to select all of the mesh, so press A. I'm going to duplicate this, so Shift D, put this up here. We'll come back into object mode. And now we've got two octopuses that are part of the same geometry. I've just got to be careful I don't get any overlaps like I'm getting here. So I'll just turn this back on here so we can see the result in edit mode. That'll allow me to go into edit mode and just move that and see the result. There we go. Now if I play this back, it's going to be a little bit slower because it's got a lot more geometry to calculate, but they are going to interact. You can see they are sort of colliding with each other rather than going through each other. So that's one way you can do it. Now it's okay, but the problem is you might want one octopus to be moving differently to the other. So for example, if I go into the physics tab and I change, let's say I want one of the octopuses to stop moving, I could go into the self collisions and set the distance to 0, but unfortunately both of them are going to stop moving. So the better solution, if we just come back into here, I'll just undo the distance there, go into edit mode, and I'm going to remove this, so X, delete all those vertices. What we'll do instead is actually duplicate the object. So I've come back into object mode, I'll Shift D, and I'll bring this up, play this back. We're getting two octopuses being simulated, but they're no longer colliding with each other, so they're not interacting with each other. To fix this, what we're going to need to do is go into the physics tab, go to the top. Let's just minimize the cloth for the second. We're going to add the collision physics modifier. And then very importantly, in the modifier stack, we're going to move it above here, just below the cloth, so that it's still acting on the low resolution mesh before we add those suckers and subdivision. That will just make sure that it stays quite fast. So we'll do the same for the other octopus. Go into physics panel, add collision, and then we'll move it in the modifier stack just below the cloth. And then if we play this back, we can see they're now interacting with each other and we're no longer getting any intersections. That's the better way to do it. And again, now what we can do is go into the physics tab for one of these octopuses. So let's choose this top one. I could come in here and I could turn down under the cloth options. We could turn down the self collisions or turn them up, whichever. We'll turn them down, play this back, and now this one's not going to be moving, but it's still it's still colliding and interacting with the other octopus. Now, one thing that you're probably going to run into is you're going to get really strange behavior like this, where the octopuses start becoming all distorted and stretched and moving around too quickly and just sort of becoming very erratic. And the reason for this is in the collision options. So let's just minimize the cloth one. Under the collision modifier here, it's all because of the thickness outer option here. If this is too high, then for some reason the octopuses, well, the cloth, the two cloth objects will start sticking to each other and going crazy. So just turn this down as far as you can. I'm going to put it all the way down to 0.001. Until if you notice problems where they're getting intersections, you might need to turn that up a little bit. And we'll do the same for the octopus. We'll turn this down to 0.001, play this back, and the simulation should remain much more stable without the geometry becoming broken. And if it's still a little bit too erratic for you, it could actually be because if we go into the physics settings, under the cloth area, so just minimise collision, the actual bending, we could be allowing the geometry to deform too much, which is letting it get too close together, and that's making it more difficult for the collision algorithm to detect whether or not it's actually colliding. So what we can do is increase the stiffness a little bit on the shear and the bending. So let's put these up to maybe let's go with point. Let's go with 1. And then for the shear, for the damping and bending, we'll just turn these up a little bit as well, maybe 0.5, just to tame it a little bit. And we'll do the same for the octopus 001. So 1 for these, and 0.5 I think it was for those. Let's just check. I mean, they don't have to be identical, but yeah, 0.5. Now we can play that back and see if this gives us a better result. And we'll just check that we've cleared the cache. So we go down inside the cloth settings, under cache, just make sure it says 0 here for both of the octopuses. Otherwise, it's going to be using the cache instead of recalculating the new settings that you've just entered. If it does say that it's got frames in memory, to clear it out, all you've got to do is just turn one of the options on and off, or off and on, and that will clear it here for both of the, you have to do that for both of the octopuses. So let's try this. And maybe we're still getting a slight bit of intersection, but just bear in mind as well, we have got the collision happening and the cloth simulation happening before the suckers. So if we just turn these suckers off, it might be that we're not getting such bad collisions, but here we can see we are. So the other option we can do is go into the physics tab and we can turn up the quality of the collision. So if I change this to maybe 6, we'll do the same for the other octopus. So this is on frame at the moment 151. We're getting quite a bit of intersecting geometry there. So let's see how this looks. And that does seem to be much better. So there's some of the options you've got to improve the quality. And of course, lastly, at the top here, we can also increase the simulation quality as well for the cloth itself. So maybe change that to 7 and do this for 7 as well. And then try again. Make sure the cache is cleared. Yeah. Play that back. And again, that's given us potentially a slightly better result still. The aim of the game really is just to use the lowest settings possible so that you get the fastest simulation without any noticeable artifacts. So let's just turn those back on, the suckers, for both of the octopuses. And next up, we'll look at the first way that we can capture a performance. And so we can have a little bit of control over the output of the animation. What we can do is actually interactively change the parameters and record that as a performance. And to demonstrate this a little bit more quickly, let's delete one of the octopuses. So I'll get rid of this top one. And we'll select this one, go into the cache, make sure we don't have any. So for example, if I press play and then stop playback and go to frame 1, if I haven't changed any of these settings, we're going to have some frames in cache. So I'll just get rid of those by turning pressure on and off. And then you see they've now gone. So I'm going to start this one off with the distance, the self-collision distance set to the lowest possible value. And if I play this back, we're initially getting no movement. And then I can turn this up a little bit until we start getting some movement. I can start modifying the various settings we've got up here. So I could turn internal springs off perhaps, so it collapses in on itself a little bit. And then maybe we could turn the compression to 0, so it can shrink in on itself as much as it wants. and then maybe turn that back up to 15 and just start modifying various ones of these parameters, maybe turn internal springs back on to start influencing the results in real time. Come down to the field weights and maybe turn gravity off so it starts floating up into the air. And then maybe turn it back on so it drops back down to the ground. And, you know, you get the idea. You can make any changes that you want, basically. And I'll stop playback. And before I go back to the first frame, what I can do is come to the cache settings for the octopus. And if you've got more than one cloth simulation, you need to do it for each object. So go into the cache area. We've got 458 frames now in memory. Now what I want to do is put that into a bake so that it's stored. I don't lose it. So we'll move the current cache to the bake. And now you see we've got the option to delete the bake. And if I play this back now, all those changes that I've made are going to be recorded and stored. So you can see everything I've done is playing back. We've not lost any of it. Now, if I delete the bake, so let's go to frame 1. I'm going to delete this bake. We've still got the 458 frames in memory. So if I don't change any of these settings now and play it back, we're still going to be getting the simulation that we recorded. So we're still going to get all that movement. So if I want to get rid of that again, we just need to turn something off and on, or just change one parameter and change it back. And then it's going to start recalculating properly the next time we press play. The next way we can start manipulating the movement of the octopus is by using force fields. So Shift A, and we're going to drop down let's try a harmonic. Put this above. And if we play back the simulation, no effect yet really, because the value for this harmonic force field is quite low. Let's change the strength to 50. You can see now it's having an effect on the octopus because it's just basically a cloth simulation. Maybe we change it to 200. It's going to suck it up. And then we could turn it off and it's going to just drop down. And let's try Shift A, maybe a wind. So let's put this underneath the octopus. We'll get rid of this one. And I'll turn the strength of this wind up to something like 50. Maybe even 500. So it's really strong. And when we play this back, it should blow the octopus upward. There you go. So it's like it's in a wind tunnel. And if we go even higher, let's set it something like 2000. Play that back. And now it's actually going to blow the octopus up in the air. Then we can set the wind back to 0. And he's going to come crashing back down to the ground. Just a disclaimer, no octopuses were harmed in the filming of this video. So there's the idea. You can try the different force fields to have an effect on the movement that way as well. And now for the really cool bit, we're going to start puppeteering this octopus. So let's get rid of the wind, X, delete that. Choose the octopus, we'll go back to frame 1. And I'm actually going to move the octopus now to the world origin. So I'll do Alt-G, it's going to put it back to the world center. And let's go into edit mode. I'm going to choose this top vertex. I'm going to Shift S and say cursor to selected. Back into object mode, Shift A, and I'm going to add an empty, and I'm going to choose a cube. We'll just scale it down a bit. And now this empty is perfectly aligned with that vertex on the top. So choose the octopus, we're going to go back into edit mode. The vertex is still selected. I'm going to control click on the empty. We'll move to the vertex menu, and then we've got the hooks option, and we can say hook the selected vertex to the selected object. So choose that one. And now if you come into object mode and move this around, it's going to pull that vertex around. Now, initially, this is going to have no effect at all on the cloth simulation. So if I play this back, the octopus is just falling down as it did before. So what we need to do is go into the octopus's physics settings, in the cloth area, down to shape, and then we need to specify a pin group, which is basically just a selection of vertices that we can have control over how much they're influenced by the cloth simulation or how much they retain their original position. So with the octopus still selected, I'm going to go into edit mode. I'm going to go into the data panel because we're going to create a new vertex group, which again is just an attribute. I'm going to call this puppet. Make sure the weight is set to 1 and I'll choose assign. So now the vertex domain has got a puppet attribute and its value for this vertex is 1. So back into object mode, into the physics settings, down to the shape again, and we'll choose this pin group. And now we've got the ability to specify the stiffness. So the higher the stiffness, the more it's going to stick to its original position, or in this case, to this empty that it's hooked to. So I'm going to leave the stiffness as 1. And now if I play the simulation back, you'll see the octopus is actually hanging in midair. And I can move this empty around and it's going to have an influence on the octopus. And I can use this in various different ways. Let's, for example, create a swim cycle so that we can create a loopable animation. Well, not loopable, but we can create an animation where the octopus can, for example, swim around a curve or a path. So let's do that. I'm going to go into orthographic view. I'm going to go back to frame 1. Make sure we've got no cache on the octopus. So just clear this cache. I'm going to choose the empty. I'm going to press play. And then I'm going to move this up and down on the z-axis to create like a swim cycle. But before I do that, I just want to remove some of this movement that it's doing itself. So we go back down to the collision settings, and I'm just going to turn the self collision right down so that it doesn't sort of instigate any self movement. I'll probably turn the weight up a little bit on the legs as well, on the mesh. Maybe set this to 0.5 so they fall down a bit faster. And the bending, let's just have a look. We're not really getting a lot of bending on there. I'd like the damping to be reduced a bit. So let's turn the damping down to something like 0.1. Let's try that. Probably still a little bit too much resistance to bending. So I'm going to turn the shear and the bending down to 0.2. Let's try this. Maybe even less. Let's go with 0. See how that looks. And maybe we'll just turn the compression down for the springs to maybe 0.1. Let's see how this looks when we move it. So GZ. Now I'm getting sort of a swimming motion. So let's just undo that. Go back to frame 1. And I'll reset the cache. And now I'm going to record the movement of this empty. Use it just by hand. So we'll press play with the empty selected. I'll just move this up and down on the z-axis to get sort of a swimming motion like this. And then we'll stop playback. And we'll go to the octopus's physics settings and just make sure that I move the current cache to bake. I'll choose the octopus. I'm on frame 307. So I'm going to go to File, Export. We'll export an alembic. And I'm going to change this to, let's call this swim cycle. I only want to export the frames that I've animated by hand. So we'll go with frame 1 to frame 300 and let's just go to frame 300. I only want to export the selected object, so the octopus. And I don't want to include the particles because I've not got any. We don't want to apply the subdivisions because if I apply the subdivisions, it's going to make the alembic file bigger because there'll be more geometry. What I can do instead is when I bring this back in, I'll just put another subdivision modifier on it. So I'll export the alembic. It should be really fast because we're only exporting this one object. And then I'll go to the file location and I'll bring in the swim cycle. I don't want to set the frame range, I want to keep my 5000 frames, and I'll choose import, go to frame 1, So select the new octopus, the alembic version. I'll move it to the side. And if we play this back now, you'll see this alembic version is an identical copy of the one that we've baked inside of the blend file. The only difference is this one's lower resolution because we didn't apply the subdivisions to keep the alembic file small. So firstly, I'll just go into the modifiers. And this is, by the way, the mesh sequence cache modifier that's responsible for loading in the alembic file. And just to get it looking smooth, I'm going to add a subdivision surface. And we'll set this to be 2 to match the original. Just check. Yeah, subdivision, this one's set to 2. And obviously this also is going to be a little bit faster to calculate because we don't have all these additional modifiers that are sort of building that octopus. So the reason I've done this is because if I want to move the position of this, so let's say for example, let's grab this octopus, I'll move it up here or rotate it. As soon as I press play, because it's baked, all the vertices are going to snap back to their baked position. So we can't move it around. Just undo that. Whereas this one, because this is an imported alembic file, we can actually move this wherever we want. And one scenario where this could be useful is, for example, if you want it to now follow along with a path. So I'm going to add a circle, Shift A. I'm going to go with a curve, circle. I'll just press F9 and I'll say align it to the view and I'll scale it up a bit. In the curve options, I'm just going to give this a little bit more resolution because it looks a bit faceted. So maybe change this to 64. And to get this octopus to follow along with the curve, we need to make it a child of the of this curve. So we're going to, with this one selected, shift click on the curve, bring up the parenting menu with Control P, and I'm going to choose to follow path. So Control P, follow path. And now to make sure it starts at the beginning of the path, which is indicated by the start of this dotted relationship line, we'll just move it down until it's in the right place. So the origin of this is approximately on the start of the path, and I'll just rotate it as well. And now when I play this back, it's going to follow along with that path. Now a few things that we're going to run into. The first problem is, if we go back to frame 1, it doesn't really start moving until it gets to about here. So what I'm going to do is go into the modifier, into the mesh sequence cache. We've got the option to modify which frame of the alembic file it's using based on the current frame here. So I want to offset it a little bit. So I'm going to bring the frame offset backwards until we get a nicer starting position. Maybe somewhere about here. And the second problem is, just bring up a timeline. If we play this back, when we get close to the end of the animation, or when we get to the end of the alembic file, it's just going to stop. It's going to keep going around the circle, but the animation is finished because there are no frames left in the alembic file that are animated. And at the moment, the frame it chooses for from the alembic file is going to be the same as the current frame. But we can override this if we go into the frame override section here, and then we can put whatever frame we want in there. So if I leave it on 1, it's going to be frame 1 all the way around. If I change it to, 89, it's going to be frame 89 all the way around. So what we need to do, I'll just put this back to 0 for the moment. We need to put a formula in here so that when it gets to the end of the file, of the frames that are in the alembic file, it goes back to the first frame of the alembic file. So just before I do this, let's turn override back off, and I want to find a frame somewhere near the end of the frames that are in the alembic file that looks similar to the first frame here after we've set that offset. So let's get towards the end of the alembic file. So it stops moving there. And we're just going to go back a little bit now until we find a frame where the octopus looks similar to how it looked on the first frame. So I think around about here, 259, that's very similar to how it looked. So what I'm going to do is loop it for 259 frames and then go back to the first frame. So we'll turn the override back on. And in a very simple equation, we're going to press hash to tell it it's going to be a driver, and then the expression is going to be open bracket frame, so the current frame that we're on, -1, close bracket, and then we're going to use modulo. So modulo is a division, but instead of giving you the result of the division, it gives you the remainder. So for example, if we're on frame 19 and our Alembic file had 10 frames in it, then it was going to be frame 19 divided by 10 is 1 with the remainder of 9. So the modulo expression is going to give us the result of 9. So it's going to use the 9th frame from the Alembic file. So let's put in the number for the frame that I want to loop to, which is 259 in my case. 259, and then just +1 on the end. Press enter, and now we've got this number here, which is going to change when I change frame. And you'll see when I go from 259 to 260, this is going to frame 1. So 259, they're going to be the same. As soon as we get to 260, it's going to go back to the first frame of the Alembic file, which means that no matter how long the timeline is, the Alembic file can loop indefinitely. But what if you want it to go a little bit slower around the circle, or you want it to go a little bit faster? Well, in that case, what we can do, go into the curve, so choose the curve, go into the curve options, and then if we go down to the path animation section, we've got here the number of frames that it takes for the child to go from the beginning of the path to the end of the path. So the beginning and the end of the path are here because it's a circle, they're in the same place. So if I want it to go faster, I can decrease the number of frames it takes to get from the start to the finish. So let's say 50, play that back, and now it's going to swim around much faster. If I want it to go slower, I'll make this number bigger, so maybe 250, and now it's going to be swimming around much slower. So just find a number that you think looks good. And if you don't want to use an Alembic, what we could do instead, if we just get rid of these two here, we could try and change the environment, the physics environment, so that the octopus is more controllable. So let's just go and choose the octopus, make sure we've cleared the cache. We'll delete the bait first and then clear the cache. If I try and animate this now by hand, just swimming all over the place, it's going to be incredibly, well, it's going to be impossible. Because we've got no water viscosity and we've got no gravity, so it's just becoming uncontrollable. So let's just delete that cache again. Right. What we can do instead is add some air viscosity. So let's turn this up to something like maybe 2. That's going to give some resistance, as if it's water, on the movement of the legs. And then we can come into the field weight and turn gravity off, so it's more of an underwater environment. And now if I try and control this, it's much better, but I am still losing control a little bit. So I'll select the octopus again, go back into the physics tab, and then just turn the air viscosity up a little bit more, maybe 3. We'll give that a try, and that's much better. I'll just move that back to the cursor, selection to cursor. And something that Andrew Price, aka the Blender Guru, might like to do if his children refuse to wash his car and he wants to get revenge by giving them nightmares, then you could add a doughnut, aka a torus, scale it up a bit, we'll apply the scale, and we'll change the snapping to faces. And now we'll move this down, press Ctrl so it snaps onto the floor. And we're going to give this a cloth simulation as well. So under cloth, under physics rather, we'll click on cloth, and we'll turn on collision as well. For the collision options, we'll set the thickness outer to the lowest value. And then for the cloth options, we'll turn on the internal springs, but maybe turn the compression down a bit so it's able to shrink down on itself, maybe 0.1. And for the octopus, we need to just turn gravity back on. And we'll get rid of the pin group now. So get rid of the puppet pin group, because I'm not controlling it anymore. We can delete the empty, And then for the octopus, we can get rid of that hook modifier as well, which was linking that vertex to the empty that we've just deleted. So get rid of that. And then for the octopus physics settings, before, you remember, if I play this back, we made it so it was able to move very freely while we're making it swim. And this has resulted in it bending a little bit too much, so the faces and things are becoming too flat, and it's, you know, not doing a very good job with the collision detection. So I'll just go back to frame 1. I'm just going to turn shear and bend into 1 for stiffness. And then for the compression, I'll set this to 1 for the damping. And for the compression on the internal springs, I'll set those to maybe, let's go with 1. Let's try this. So that's better. And if we just Control 2 on the doughnut to add a subdivision modifier, right click, shade smooth, and now we've got something that is particularly horrific. And if it's a little bit slow to come through the air, that's probably because if we choose the octopus, we've still got the air viscosity set to 3. So put that back to 1 and give that a try. It should be more like air instead of underwater. There we are. But the increased speed of the octopus has caused the doughnut to gyrate a little bit too frantically. So we'll come back down to the doughnut settings and we'll just maybe increase the compression to something like, let's go with 12. And then for the collisions, let's just turn these down a bit so they don't sort of jump up when it hits the floor. There we go. There we go. So that's a little bit more stable. And if you want to, you can turn back up the collisions on the octopus. So choose the octopus, turn those self collisions back up to start getting the octopus a little bit active again. So let's see how we can make this octopus breathe. So in the cloth options, we'll go to the pressure settings. Let's turn pressure on. We'll just bring up a graph editor. Make sure we're on frame 1. And we can add a keyframe for pressure. So hover over the pressure value and press I to add a keyframe, which you can see now in the graph editor. And this basically means that we can now add an animation modifier. So if we go into the modifiers tab in the graph editor, and we can add a built-in function. And we'll go with a sine wave because that'll fit nicely with the breathing pattern. We basically want this pressure to go up and down over the period of maybe a second. So let's look at the frames per second is 24. So if I zoom in, I want this 1/2 of the sine wave to cover 24 frames. So basically it's going to breathe in and then out over 24 frames. So we'll just modify the values here. Firstly, we'll move the value offset. So make it so it's on the 0 line. And then I want to expand the range of it so it covers approximately 24 frames. So we'll do the phase multiple, just turn that down. We'll slide it across a bit so it starts exhaled. And maybe we'll bring that a little bit more. So around about there. So it's breathe in and then out. If we play this back, we're not really seeing much happening at the moment because basically the settings, the other physics settings like the tension and the compression are being too restrictive. They're restricting that movement that's been caused by the pressure. So what we could try is turning up the amplitude a bit more, or we could change the pressure scale. So let's firstly try the pressure scale. So play it back and I'll turn it up to 2. See if we get any movement. We do get a little bit of movement there. Let's try 3. Maybe 4. 5. 6. 8. And now with 8, I'm just going to turn it off, see if anything happens. So we're getting no change. So that's not enough. We'll go with 16. And now we are starting to see some movement. And let's go with maybe 20. You just got to be careful not to go too high. otherwise your octopus is probably going to explode. So there we are, we've got a definite breathing movement, but the thing is, it's happening everywhere. I think it would make more sense if it only breathed with its head. So luckily the pressure, and all of these options actually, have got a vertex group input, so we can limit the effect of this to certain vertices. So we go into edit mode. I'm going to select all of these vertices on the head except the ones that are surrounding the legs, because if I choose the ones that the legs are connected to, then this value, this attribute that I'm going to add to these vertices will also extend down the legs, if you remember from before. So Control plus until we've got all of the ones except the ones that are touching the legs. So up to there. I'll go into the data panel, we'll create a new vertex group, and I'll call this one breathing, and I'll assign these vertices I've got selected a value of 1. So click assign, and then we'll go back to the physics tab, we'll go down to the pressure, and I'll say only affect the vertices whose breathing attribute value is equal to 1. So come back out. I need to go back to frame 1, and I'll turn it off initially so that it can fall down. We'll probably just turn off the self-collision as well, or turn it down rather. So it falls down. We're not really getting much of any movement, so now we can turn up the self-collision a little bit to get those legs moving. Maybe not quite that much, don't want it to climb out. So something like that. And now we can turn that pressure back on. And we're going to start seeing the head only breathing with this pressure. So that's something useful to know. You can also control all these parameters with the graph editor, with keyframes, and with these built-in animation modifiers. Right, so let's get rid of the donut. We don't need that anymore. And we'll go back to frame 1. And for the octopus, I think I'll turn off the pressure. I'm not going to use the breathing just yet. And the first thing I want to do is just get a nice movement on this octopus before I start building the scene. So let's just turn down the distance for the self-collisions initially. And we can get rid of this graph editor now. And we'll go back to frame 1. Play that back. And I just want to check there's no parts of the mesh that are becoming too sort of collapsed that might lead to problems with the movement. As we can see there, that leg has become way too squashed and we've got bits of the inner extrusion coming through. So let's start with a clean slate by getting rid of all the deformation. We'll turn up the compression and the tension in the internal springs, and then we'll go to the stiffness values and we'll turn these quite high to 15. And now we can start reducing the bending and the shear until we get an acceptable amount of deformation that isn't going to lead to any sort of parts of the geometry collapsing to the extent where the collision detection breaks and it leads to erratic movement. And now let's try turning up the self-collision, just to make sure we're not getting any overlapping geometry when it starts moving around. And this is looking pretty good. So next up, we're going to move on with actually building the scene. So I'll use the plane, turn on overlays. I'm going to scale it, so go into top view. Just want to scale it so there's enough space for 2 octopuses to run around in. So maybe about here, perhaps. We'll apply the scale, Control A. And then we'll go into edit mode with face mode selected. So number 3, select face mode. Select the face, we'll press I to inset it. And then I want to extrude the outer area, so Alt click on that edge. We'll extrude that. Maybe a bit higher in fact, so GZ to move that up. Okay, and what we'll need to do is fill the bottom in. So number 2 for edge mode, we'll Alt click on the bottom edge, so it selects the loop all the way around. I'll just move that down a bit, so GZ, and then we'll press F to fill it in. And I'll just check that this is now, all the normals are pointing outwards. So we'll go into the overlays, turn on face orientation, and just check that everything is blue. So it is, that's good. We'll turn those back off. And the next thing I'm going to do is add a few objects for the octopus to interact with. Back into object mode, Shift A. I'm going to go with its cylinder. and we'll also go with a monkey. We'll move these into place. We'll duplicate it. Maybe somewhere about there. Bring the monkey over here and rotate him around a bit. Something like that. And I'll probably just tweak the scale and things a little bit more, just to make it fit more with the size of the octopus. And then I'll select both these cylinders and we'll edit them together, just to add a little bit of a bevel. I'll select the top face, and I'll go into isolation mode, and I'll press Shift G, and I'll say select other faces that have got a similar area. So that's going to select all those big faces. I'm just going to do a bevel now, so Control B, add a bevel, and use the mouse wheel to add a few segments. Right click, and then shade smooth. And then we'll do the same for the monkey. I'll right click, shade smooth. And for the monkey, I'm going to use a subdivision modifier instead of doing it manually in edit mode. This will mean that I can put the collision modifier above the subdivision modifier so that it can work on the lower resolution geometry for more performance. I'll turn this up to 2, and there we go. We now need to make these 3 new objects into collision objects. So we're going to the physics panel, collision, and just set the thickness outer, just turn that down a bit, and then we'll do the same for the other 2 objects. If we play this back, we should get the octopus interacting with these objects. Yeah, so that's looking pretty good. And for these collision objects, because they're not single-sided, we need to just make sure under the collision properties we turn single-sided off so we get the correct behavior. So do that for the monkey as well. And we'll also do the same for the floor, or the pool now. So turn off single-sided. And I also need to make sure that for these objects here, not the octopus, importantly, but for these other objects, I make the scale 1. So let's select all these, Control A, apply the scale, and then finally, for the pool, I'm going to go into edit mode and just add a bit of a bevel. So I'm going to select all of the edges, number 2 for edge mode, press A, Control B, add a bevel, and just add a few segments as well. And there we go. And we'll do right click, shade smooth. And if you get any weird shading on there, you can go into the modifiers and just add a weighted normal, if you can find it. Just type W. So weighted normal, and that's just going to help get a decent normals on those large faces where there's insufficient geometry to make sure that the normals are, nice and flat on those areas. And then just try the different options to see which gives you the best result. I'm going to go into top view, move the octopus to here. I'll grab another one. I'm actually going to grab these and bring these across. Gives ourselves a bit more space for the second one. Shift D, and bring this one over here. And just make sure we're not getting any intersections. And I think maybe I'm going to scale this up a little bit, this pull. So S, Shift Z, so it doesn't scale on the Z axis, just so that octopus has got a little bit more space to land. And apply that scale. Let's play this back, make sure the octopuses aren't intersecting at the start, so that's fine. So play that back, and now these octopuses are going to start moving around and at some point interacting with each other. And if you want one of the octopuses to move a little bit more than the other one, we can come into the physics panel and just start playing with the various settings we've got. And I think perhaps I'll make the second octopus a little bit more rambunctious by turning up the distance a little bit. And now he's moving around in a much more irate, aggressive manner. And there we go, so I'm pretty happy with that. What I can do at this point is bake the animation for the octopuses. So if I don't want to manually change things, which I might want to, I'm not sure yet, let's just see what it looks like if I bake them. So I'm going to bake both of the octopuses. Basically, I'm going to go into the physics tab with one of them selected, down to the cache area, under the cloth settings, and I'm going to say bake all dynamics. This will bake both of the octopuses rather than just the one that I've got selected. So bake all dynamics, and we can go all the way to 5,000 if we want to, or we can reduce this a little bit now. So I'm probably going to bring it down to maybe, let's go with 2,000. for the frame range, and I'll do for the cache for both of the octopuses. We're going to go into the cache area, and I'll set this to 2000 as well, just so it's a little bit faster for the tutorial, but you can make it as long as you want. So 2000, and now I'm going to say bake all dynamics, and it's going to start baking the dynamics, and you can see there the progress, and I'll come back in a second when that's finished. So that's finished now, and you can see we've got the option to delete the bake, and just check we've got that on both octopuses. So we've got all those 2000 frames recorded basically, and then I'll scrub through the timeline, find a decent area of the animation, and then set the start on end frame to surround that area. So once you've set the start on end frame around the most interesting region of your simulation, we can now add the water and get it interacting with the octopus's movement. Right, so let's get rid of the timeline for now. I'm going to do Shift A. We'll add a plane. This is going to be for the water. I'll go into top view, and then we'll scale it up and align it with the pool. Go into solid view. Just need to move it down a bit now until we've got the octopus poking out. And we need to give it plenty of subdivisions so that it can deform, for the waves of the water. Control A, apply the scale. Then we'll go into edit mode. I'm going to subdivide it, so right click and we'll choose subdivide. And I'll press Shift R a few times until we've got plenty of subdivisions. And now what we need to do is get the octopuses to generate waves when they thrash around inside of it. And in order to do this, it's pretty straightforward actually. We're going to set this plane to be a dynamic paint canvas. So click on dynamic paint under the physics tab and then choose add canvas. And I want to set this to be, instead of paint, I want to set it to be waves. And we can have multiple of these if we want, by the way. We can just stick the plus and we can add another one just in case we also want to paint onto this as well. Maybe if we want to add foam around where the octopus hits the water. But for now, I'm just going to go with waves. And I'm going to change the speed. I find the speed is better at 0.5. That should be fine. And then we need something to paint onto this canvas, and that's going to be the octopuses. So choose the octopus. We'll just minimize the other physics properties. And we'll click on dynamic paint. And I want to set this to be, instead of a canvas, this is going to be a brush. And then we've got various options. If we just click on add brush, we've got various options in here of how we want it to interact. So how we want it to paint onto this canvas. So I'll leave all these as default, and under the waves, I just want to turn up the factor a bit and maybe make it 2 so that it has a stronger impact on the waves. We can always tweak them afterwards if we want to. And now I'm going to do the same for this octopus. So dynamic paint, make it a brush, and then we'll say add brush, and then I'll change the factor of the waves to 2 again. Now, very importantly, to make this simulation fast, we go into the modifiers for both of the octopuses, and we need to move this dynamic paint to the low resolution version without the suckers. So let's move this so that it's just underneath the collision, just before this suckers geometry node here. And we'll do the same for this one. That'll keep it nice and fast. And I'll go into wireframe, and I'll just turn X-ray off so I can only see the surface. And we'll go back to the first frame, and we'll play this back, and we can already see it's having an impact around here. But play it back, and we can see that the movement of the octopuses is now generating waves on that water. And if you don't think there's enough resolution, if it looks a bit too, not enough detail, we can always go in here into edit mode, and we can just add one more subdivision. It will make it slower, of course, but we'll give it a try. That's pretty fast, actually. It didn't make too much of a difference, but now the waves are looking much better, particularly when we start adding the materials in a second. But one thing you're going to notice is that the waves are travelling straight through these objects. So in reality, these would be reflecting the water. So to fix this, we'll select one of the cylinders, and then we'll go into the physics tab, And we're going to give these a dynamic paint, and we're going to set them to be a brush. Add the brush, but this time, instead of it affecting the depth, I just want it to reflect only. So it's not going to sort of create waves, it's just going to reflect waves. So choose reflect only, and we'll do the same for this one. Dynamic paint, add the brush, and make it reflect only. And then we'll do the same for the monkey as well. So just give that a dynamic paint, make it a brush, and reflect only. And for the monkey, go into modifiers, we'll just put this dynamic paint before the subdivision so that it's faster. We'll do the same for the collision as well. Right, so next up we'll start looking at how we can make it look super realistic by setting up some materials and the EV render engine. And we'll also make the camera movement look realistic as well. Okay, so let's open up a shader editor. We'll zoom out a bit, we'll turn overlays off, and we're going to change the render engine to EV, just the standard EV, not EV Next. And then we're going to change the viewport to be material preview mode at the top here, just the middle one there. Right, just hide this panel, press N. In the options for the viewport, turn the opacity of the world to 1 so we can see it, and then turn the blur right down. And I'll stick with this current environment map. And then we're going to click on the pool object. And let's just turn this grid off. So under overlays, I'll turn off the floor. And we'll turn off the X and Y as well now. Right, so I've chosen the pool. We'll say new material. And it's going to give us the principled BSDF. What I want to do is connect this up to some actual textures to give us a more realistic look. So with this one selected, the principled node, Control-Shift-T, making sure you've got the Node Wrangler add-on installed. It comes with Blender. And if you're not sure how to enable an add-on, it's just Edit, Preferences, Add-ons, and just search for Node Wrangler. Then just put a tick in the box there. Alright, so Control-Shift-T, it's going to bring us up a special window which we can automatically choose the textures that we want this material to be, and it will wire it all up for us. So we're going to go to wherever your textures are. I'm going to go to marble. I'll make this available, by the way, if you want to check in the download folder. And then I'm going to go with black marble. Let's look at the maps that we've got. So we've got displacement, roughness, so that's the glossiness, the colour, and then the normal. So I'm going to go with these three: roughness, colour, and normal. I'm not bothered about the displacement. And we'll say principled textures. Click on that. And what it's done, it's wired it all up for us. So now we've got this material created and we didn't have to do anything at all. You're probably going to want to change the normal though to, instead of sRGB, change this to non-colour. Usually works better. Okay, so we've got the marble on there, but it's not mapped correctly. What we're going to need to do is either unwrap this, or we can just cheat and change the textures to be, instead of being flat, we'll change these to box. So I'll do this for all three. And then we'll change it from UV here to either generated or object. Let's try object. We'll try generated. That's better. So generated basically does it from a bounding box around the entire object, whereas object does it based on the position of the vertices relative to the origin. So at the corners, if you see a seam between the textures, then just go into each of the textures and turn up the blend a little bit, and that will smoothen that out. And then finally, for the coordinates, I want them to be stretched out on the Z, because at the moment, the height of the texture is being squashed down, whereas the top is looking pretty good. So to do this, I'm going to go over here to the scale, and I'm just going to change the Z, so just reduce the Z until the texture doesn't look so squashed down on the vertical axis. And we can also modify on the other two axes as well, if we want to. What we're going to do now is the water. So we'll click on the water and we'll say new material. I'll just call this one water, and I'll call the other one, let's choose that again, call that marble. Click the water and just find the nodes it's created. Right, and water is very straightforward. We're just going to change the transmission, give that a transmission weight of 1. And we can't see much at the moment because we need to go into the material properties, either in the panel over here, or we can press N and go to the material options here. We need to turn refraction on. So ray trace refraction, turn that on. And then in the render settings, we also need to enable refraction. So turn on screen space reflections, and then open that up and turn on refraction. And now we can see through. And we need to turn the roughness down so that it's more like water. For the IOR, water has got an IOR of 1.33. And you'll see we're getting this weird effect here on the edge of the water there. If we just modify the refraction depth slightly, we can modify that until it fits. So just drag it with shift held down until it fits properly. Basically you want it probably the lowest value you can. Let's try 0.001. But we have got a slight problem here at the bottom left hand corner. We're losing details like towards the edge of the screen, like there. We're starting to see the actual ground through the pool. So what we need to do to fix that, in the render settings, just turn the edge fade in all the way down, and that'll fix that. Alright, so let's just play this back. You can see we're getting the nice waves on the water. And then to speed up the viewport, we'll go to the planes physics settings, under the cache, for the dynamic paint, and we'll just choose to bake the animation. Should be pretty fast. And the dynamic paint baking is a little bit temperamental. You might find if you save the blend file under a different name, or you close and reopen Blender, you're going to lose that, and you're going to have to delete the bake and then rebake it again. Just something to bear in mind. But if we play this back now, it should be a little bit faster because we're not actually calculating during playback. Under water resolution, we can see the faceting, so right click and choose shade smooth, and that will improve that. And if it still looks a bit blocky, you can always go in here and add a subdivision surface to it, and that'll just make it a bit smoother. So let's move on to the monkey and the 2 cylinders. I'll choose this one, say new material, and I'll make this one maybe red, make it glossy. This one, make this one maybe blue, and we'll make that glossy as well. And then for the monkey, I'm going to make that one yellow, and we'll probably make that one glossy as well. And then for the octopuses, we'll choose one of them, and we'll say new. And I want to make this material feel like skin, so I'm going to use subsurface scattering. So go into subsurface. I'm just going to turn the weight up to 1, and then we need to go into the properties for the material. We'll go down here this time, and just turn subsurface on here, and then we can turn the scale up until we start getting an effect. So I'm going to have this octopus be 2 colours. So we'll do Shift A. I'm going to put down a mix colour. Plug this into the base colour. I'm going to have it be white and red. And then I want this to be controlled, instead of being controlled by just a set number, 0 to 1, which it chooses between the top and the bottom socket. So 0 is the top socket, 1 is the bottom socket. What I'm going to do is control this with a noise texture. So Shift A, search for noise texture, and we'll drop the factor of this into the factor here. And now the black and white noise texture is giving us a non-uniform distribution of colours over the mesh. And if we want to make it a little bit stronger, Shift A, and we'll look for a ramp, drop this here, and now we can drag the darks and the whites closer to each other to increase the contrast. Let's play this. Just make sure that the noise texture is sticking to the geometry. And if it isn't, then we can create custom UVs in the geometry node network, but this seems to be working fine, so we're all good. Now we can just modify this until we get a look we like. Make it a bit glossy, so we'll keep the roughness up. I don't want it all to be glossy like that, but I want it to use the coat, so we get sort of the wet effect on the sides, the glancing angles of the octopus. So we'll turn the weight of the coat up, and then we'll decrease the IOR so that it only appears more prominently on the glancing faces of the octopus. So if I go with something like 1.1, maybe that's a bit too low, go a little bit higher. And now the coat is strongest at glancing angles. We can tweak this in a second. We'll click on this one, then we'll shift click on this one, Control L to link, and I'll press M, the materials. And now this one has got the same material. Right, so next up, let's start aligning a camera. So we're going to do Shift A. We'll just turn on overlays. So Shift A, I'm going to add a camera. And we can either press Ctrl Alt 0 to automatically align the camera to the view, or we can press F3 and just search for align camera, and then it's going to give you the shortcut there as well. So click on that. The camera is now lined up with the viewport. If we go to the camera settings, we can play about with the focal length until we get a view that we like. We'll open up the end panel, go to the view, and I'll say lock the camera to the viewport. And now we can move the camera around with the normal viewport controls. And to fill this entire area, I'm going to press home. So let's just get an angle that I like, maybe somewhere about here. And I want to add some shadows now around the object. So we're going to the render options, and we're going to turn on ambient occlusion, and then we're going to turn up the distance until it gets a nice result. And then we can modify the factor to make those fake shadows a little bit stronger if we want to. I think I'll go with something like 2. And now we can go to the camera options, and just to make it easier to see what we're working with, we'll go under the viewport display and turn up pass up per 2 all the way to the full. And now we're only getting the areas inside of the camera. At this point, I might want to just rotate the world environment a little bit. So let's go in here, and we can actually rotate the environment until we get a look of sort of lighting and reflections that we like the look of. And the next thing we can do is add a little bit of depth of field, because obviously the background that we're using in the material preview isn't very high quality. And also it will make it just look a little bit nicer anyway. So into the camera options, we'll go to depth of field, put a tick in there. I'm going to choose a focal distance. So hover over this and press E to bring up the eyedropper. And now we can click on a distance I want. So I want to focus around about here on this octopus. And now I can turn down the f-stop to get the level of blur that I want. So maybe 0.5, maybe even 0.1. A bit too much, 0.2 perhaps, 0.3, maybe 0.4. Yeah, I think 0.4 looks pretty good. What we need to do now is get some movement on that camera so it feels as though someone is actually holding the camera. So with the camera selected, we're going to change this bottom shader editor into a graph editor. I'll bring this up a little bit. I'll just press home again to refill the viewport. And we'll zoom into the timeline, the range that we're going to be rendering, and go to first frame, and I want to press I, making sure again the camera is selected, and choose to add a keyframe for rotation. So now, if you look over here, we've got, just turn it down a bit, we've got X, Y, and Z rotations have now got a keyframe. If you press home, it's going to take us in, zoom in so we can see where they are. Now what this means is we can now use an animation modifier, just like we did earlier with the octopus. So I'm going to select all 3 of these channels. So make sure they turn yellow. Or if you're in Blender before version 4, then you're going to have to do what I'm about to do now, but for each one of these individually, rather than all at once. But the process is identical. So I'm going to do it for all 3. I'm going to Modifiers tab, and I'm going to add a new modifier, and this time it's going to be a noise modifier. So now all 3 of those that I had selected have been given a noise modifier to modify you know, what to modify the rotation values of each of the channels. So if we play this back, we're going to get a crazy result because it's way too fast. So what we need to do is just making sure I've still got all three selected. If I turn the scale down, it's only doing one of them. But if I alt drag, because all three of those channels are still selected, it will modify them all at once. So I've just increased that scale so that the noise isn't as fast. It's going to be over a longer frame range. Otherwise, it's going to look like your cameraman's using a pneumatic drill. So I'll probably turn that scale up even more just to make it much gentler and a slower movement. Maybe something like this. And then obviously it's moving around way too much. So I'm going to alt drag and bring these down a bit as well. Or for more accuracy, you can alt click and then enter the number manually. And it will still affect all three of the selected channels. And just so we can see this better, let's go to wireframe mode because we should get better performance with Eevee not trying to calculate the materials. So we're not really getting a lot of movement at the moment. So I'm going to come back in here, still got all three selected. I'm just going to turn that strength up a little bit. And now I want to offset all three of these. So at this point, I'll choose them individually. I'll choose the Y and I'll say offset it, just so the noise patterns aren't matching up precisely. Let's move that around. And then we'll do the same for the Z. Let's play this back. So I would say it's too slow, but the strength is too big. So I'm going to select all three. I'm going to reduce the scale so that the speed is higher because the noise will be happening faster. Try that. So that's probably a bit better, but now the movement is too big. So let's go to the strength and alt click. I'm going to put 0.03. Let's try that. And basically just play around with the scale, the strength and the offsets until you get a movement that you feel is like a realistic handheld camera. So I'm quite liking that. Now let's go back to the material preview mode. And the last thing we're going to do to make this more realistic is add a little bit of a sort of composition, a bit of post-production to it. But we're going to do it before we render. And we can do that thanks to the real-time compositor. So let's go and change this now to the compositor editor. And then to get the compositor changes we make to show up, we'll go to the viewport shading options and turn on the compositor for either the camera or always. We'll go with always. And what we can do is start adding some effects to this to make it look a bit more realistic. So Shift A, put down an RGB curve node. So this gives us a curve, which we can use then to either change the bright areas on the right hand side, like so, the dark areas on the left hand side, like that, and then the mid-range, so the gamma, we can bring it down or we can bring it up to make it brighter whilst maintaining the same same dark and light levels. And if we want to add contrast, we can bring this side down a bit, so the dark's down and the white's up, and that will give us more contrast. And then if we want to after that, we can copy this one, Shift D, we'll just get rid of one of these, and then bring that brightness back up a bit in the middle. You've just got to be careful not to push the gamma too high, otherwise you could start losing details in the reflections. Okay, so with that done, what we can now do is render this out. Now, there's two ways we can do it. We can either render the animation, so under render and then render animation, Control F12, or the much faster way to do it, if we're using Eevee, is to do a viewport animation instead. So firstly, let's choose a location to output this animation to. So // to choose to output it to the same location as the blend file. We'll call the folder render, and then for the file name, I'll call this tutorial version .mp4, and then I'll change the file format to be FFmpeg, and I'm going to change the encoding to be MPEG-4, just so I can use it in my DaVinci Resolve. And for a little bit more realism, we'll also drop down a lens distortion node. so that we can add a little bit of dispersion. So that's where the red, green and blue channels will become separated towards the edges to mimic the sort of distortion you might get in a real camera. So you don't want it too high. If you go too high, then it's going to look ridiculous. So maybe 0.02 or 0.03, just something subtle, but it will make a difference to the viewer. And then just to make a few final tweaks. And I'll just go back into the shader editor and make a few tweaks to the octopuses. I might give them a little bit more subsurface just by turning up the scale. Let's put this to 10. And I'll probably make one of the octopuses a different colour. And this number 2 shows us that there are 2 objects using this material. So I'll just rename this first to red octopus. I'll click the number, which will create a duplicate, and this now the selected octopus is using this red octopus.001. So I'll modify its colour, maybe make it a purple blue. I think green looks pretty good. Yeah, that's a pretty interesting colour. And I think I'll probably bring it down a little bit. Maybe somewhere about there. Let's make it a little bit less contrasty. Something like that. I think I'll do the same for this one actually. Then we'll select the green octopus so we can change its colour, and we'll call this one, this material, green octopus, as you might have guessed. Now I'm going to show you how to do a viewport render, but don't follow along just yet because there's going to be a problem. So click on view and then click on viewport render animation. And you'll find quite often that the viewport render is about 10 times faster than the standard Ctrl F12 render. But I'll leave this to finish and then I'll come back in a second and show you the problem that I was talking about. So if I play this result back, you see we've got a problem. Basically, we've got the camera area in the middle, but then we've got this big area outside of where I actually wanted to be recording. So in order to fix this, what we need to do is make sure that the viewport, the panel, perfectly fits the camera. So to do this, all we're going to do is drag this across and then press home so that it's fitting perfectly at the edges, and then just bring the bottom up until that fits with the bottom as well. So as soon as that bottom white line disappears, you can do it again and it's going to work. And I can render this out again. And just a few improvements I'm going to make after seeing the previous result. Firstly, the shadows. So I want to decrease the distance on the ambient occlusion to something, I think probably 5 is going to work better. Maybe just for good measure, we'll turn up the trace precision. And we can turn off half res trace so we get better quality in the screen space reflections and refractions. And then to get it to render a little bit faster, you can reduce the number of samples. So if I turn the viewport samples down to 8, it should render quite a bit faster. And I also want to turn off viewport denoising as well, just so I don't get any weird sort of artifacts. And finally, I want to change the start frame to be a few frames later so that there are some waves initially when the video starts. So maybe about there, and that's going to be frame 1626. So let's go over here into the output, and I'll just change the first frame to 1626, put it back over here, and make sure we've got overlays turned off, obviously, before we render, because we don't want those to be included in the viewport render. And then one last tweak, I'm just going to go in here and just turn up the blur a little bit on that background, just to make it a little bit less intrusive, I think. Maybe something like that. So viewport render animation. And here's the final result, and I think it's looking pretty good actually, probably even better than the original one that I made. So I hope you've enjoyed the course. I hope you've learned plenty of stuff you can carry over into your own work. And if you're not aware, I've also got an incredibly in-depth 18-hour course available, which will take your skill levels in Blender to a whole different stratosphere. It's suitable for both beginners or advanced users or people coming from different 3D software. By the end of the course, you'll have a professional level understanding of virtually every aspect of 3D, and you'll be able to create virtually anything you want, and in actual fact, by the end of the course, you'll have created this scene completely from scratch. And you can watch the entire course completely for free at my YouTube homepage, so youtube.com/3D-illusions. It's this playlist just here. So it's actually multiple playlists. And if you want to watch it ad-free, you can also find it on Udemy, which has usually got quite a decent discount as well. If you do watch it on Udemy, then I'd certainly appreciate if you use my link in the description below. Otherwise, I have to pay Udemy a marketing fee. So all the best, and I will catch you in the next one.